Devlog, where I blah about de. Continuing forward on my as of yet untitled sokoban game, working towards getting all the pieces together for a prototype. Given that I'm doing this whole project solo, I took a moment to really assess where my skill gaps are. Art and design are definitely at the top of that list, so I've been working on building those skills out. Given that I'm working in pixel art for this project, I've been testing out different workflows, primarily testing against Krita, LibreSprite, Pixelorama, and Asprite. I've also tentatively been looking at a Blender to pixel art pipeline, but haven't gotten too deep into that yet. I put together some new placeholder art for proximity mines while I was working in Pixelorama, replaced the temp art that was in the game previously with this new art. It's not right, but having the wrong thing in there is better than having nothing. It usually helps me to point the right direction towards the right thing. I knew I was going to be working on a laser cannon this week, did some design work on that, this time in Asprite. Came up with two variations. I dropped the second one in the game as a placeholder art for the laser cannon, which I implemented at the beginning of this week. The laser cannon is a static object, and that means it can be pushed around but doesn't move on its own. It uses a direct line of sight. If it sees the player, it will fire the laser and the player is destroyed. If there's something between the cannon and the player, whether that's a wall, an enemy, or a static object, its view is blocked and it won't fire. As I was working on this entity, I started to feel like implementing additional navigation was getting chunky. As much as I hated to go back and do a refactor this early in the process, it was necessary. All four enemies, the player, and the static objects were responsible for their own movement. The level held all the tile map data, but all entities would just call into the map for tile states and move on their own. Adding new entities wasn't going quickly, and there was enough navigation-related code in the level class that it was starting to feel bloated. I pulled all the tile map data management into a new auto load that also manages a single A-star grid 2D instance for chaser movement. There are a few things going on in the nav manager, but the primary ones for enemies are the pick tile process moves and get processed moves functions. All enemies except for the chaser have a direction that they're moving in, and when it's the enemy's turn to pick their next tile, they submit up to the nav manager their current tile and their desired next tile based on the direction that they're moving. Chasers are the exception, and they submit a vector of 0, 0 for their target tile, as their moves rely on A-star pathing. This is saved in a dictionary, since only a single entity can exist on any tile. This is a reliable method of identifying which entity made the request for the target tile. Once all the requests are into pick tile, then it runs process moves. This iterates through each of the moves. For chasers, it checks the A-star instance for a path to the player and grabs the first step in that path, replacing the vector 0 in the dictionary. It then iterates through each desired position in the dictionary to see if it's available in the tile map. If a position is available, it marks the requesting enemy's current position as available. It then pushes the validated move into a new dictionary containing the enemy's current position and the process target position before that original entry is removed from the initial dictionary. This triggers the initial dictionary to be reprocessed. This will continue until the initial dictionary is either empty or none of the remaining moves are possible due to the blocked tiles. At that point, any remaining blocked moves are added to the process move dictionary with the current and target position set to the current position of that enemy, effectively a null move. Enemies then each call get processed moves with their current position to get their next position. Once they have that data, then they can commit their moves. This was a necessary change for the case where two or more adjacent enemies are trying to move in the same direction. So in this example, we have 3 tiles and 2 enemies. The tile on the right is open, and both enemies are trying to move to the right. In my initial implementation of movement at the enemy level, it depended on the order the enemies were processed. If the enemy on the middle tile was processed first, things would work out just fine. It would see that the target tile is empty, mark that tile as solid, mark its current tile as empty, and move. Then the left enemy would check. It would see the middle tile is empty, mark it solid, make its current tile empty, and move. If we flip that processing order, it breaks. The left enemy checks and sees that the middle tile is currently occupied and then it can't move. The middle enemy then checks and moves as before. We end up with 2 completely different outputs, depending on processing order. I could and did just call the move process twice in a row. Since the middle enemy had already moved after the first turn, the left enemy would be able to move into the now vacant center position. The problem here is that as you stack more enemies in a line, you would need to call the move process once for each enemy to ensure that it would work in every processing order. By putting it into a loop and iterating over it, it doesn't matter how many enemies are in that line. They will all get processed appropriately. The other piece of major work this week was the bully bot. It's also a static object. It monitors the space directly in front of itself, and if the player, an enemy, or another static object is placed into that monitor space, the bully bot will push it away. If the spot it's pushing entities into is occupied, say a wall or another static object, then the entity will be destroyed. These can also be chained, and all the steps will run sequentially within a single turn for as many bully bots as can feed into each other. The only thing that won't work is an infinite loop. There's a tiny bit of monitoring on each bully to keep track of what entities they've seen in a given turn. If an entity is seen twice on the same turn, it indicates an infinite loop. At that point, it will call for the entity to be destroyed. There's a new build up on itch. The link is in the description if you want to play with it. There are at least a few bugs that I know about, and I still need to do some proper levels, but I'm really close to having a functional prototype done. I didn't get as much done as I would have liked to this week. A fair amount of time is being committed to job searching because I am unemployed, and I need to find my way back to having an income again. With unemployment in mind, I've got a Ko-fi page where you can support my work. I pushed a custom sticker I designed up to my Ko-fi store. It's roughly 3 by 3 inches, and it's a nice looking print on quality vinyl. It is available for purchase and shipping if you're into that kind of thing. I'll probably have another devlog in about a week or so. I plan to take care of those outstanding bugs while I build a handful of actual levels. That's what I'm planning to have completed before the next devlog.